So we're here to talk about velocity, more specifically, how it relates to calculus, and how it involves the first derivative. Alright, so let's get into this. If I give you the equation s of t equals 3t, let's call that the position equation. That's going to go ahead and tell me where an object is at any point in time, where t is going to be measured in seconds. I can graph s of t equals 3t. I start by plotting the y-intercept at 0, 0. I use the slope up 3 over 1, go up 3 over 1 again, and you can connect and make the green line. I'm going to go ahead and place time in seconds on my x-axis, and s of t, my position, in meters on the y-axis. I now have an equation that's going to give me the position at any time. If I take the derivative of that green equation, I would have the velocity. Velocity is the derivative of position. This is going to give me my speed. So v of t, for velocity, the derivative of 3t, is 3 meters per second. I can also denote this s prime of t. Now I can get the velocity at any time. And if you notice, the velocity is the same at any time because it's constant at 3. If I want to know where I'm at 4 seconds, I'm going 3 meters per second. If I take the derivative of velocity, I'll get acceleration. Acceleration is the derivative of velocity, and velocity is the derivative of position. So the acceleration is going to tell me how fast my velocities are changing. How fast is my rate of change changing? For this one, the derivative of velocity, the derivative of 3, equals 0. My velocities aren't changing. The velocities are constant. So a, for acceleration, a of t, is going to be the same thing as s double prime, the second derivative. Acceleration is the second derivative, velocity is the first derivative. Here's the relationship between all three. So check out the notation I'm using. S of t for position, s prime, my first derivative for velocity, which is v, and s double prime for acceleration, which is the same thing as v prime, or a of t. Okay, let's take this to the real world. Where can I actually use these things in the real life setting? So here I am cruising around on my dirt bike, and I know what you're thinking. What's the first thing you think about when you're riding a dirt bike? It's calculus. At least that's what I'm thinking when I'm riding a dirt bike. Well, actually, I am using calculus anytime I'm riding a dirt bike. Here's how. Suppose I want to know the maximum height of that jump that I just hit right there. I can use calculus to figure this out. If I had the equation for my position, h of t equals negative 16t squared plus 38, I can calculate the max height. Let me show you how to do that. The max height occurs at the vertex of my parabolic flight path. At that vertex, the max, the tangent line has a slope of 0. Well, derivatives will give me the slope of the tangent line. So the slope of that red line equals 0, and I can take the derivative of h of t. Using the power rule, I get negative 32t plus 38. And now I'm going to want to set that derivative equal to 0 to solve for what time? So I'm going to subtract 38, divide by negative 32, and I'm going to get a time that I'm going to round up to 1.19 seconds. If I want to know what the max height is now, I can plug that time into my original position equation, h of t. So the h of 1.19 is going to give me 22.56. Oh yeah, by the way, I forgot to mention, time is going to be in seconds here, and the height is going to be in meters. So at a time of 1.19 seconds, I am currently 22.56 meters above the ground. Now I'm also adding this from 0, not just the distance from the center of the jump to my bike, but actually the dirt pile itself, if you thought that was a little bit high. Question B. Now I want to know when my velocity is going to be 10 meters per second. I already have an equation for the velocity, negative 32t plus 38. Now I want to know when is that going to equal 10. Well, just set the first derivative equal to 10 and solve for t. So in doing that, I'll get a time of 0.875 seconds. So already within 1 second of the jump, I'm going at a rate of 10 meters per second. Question C, what is the velocity at 2 seconds? So I've already gone past the maximum, and now I'm on my way back down. So I'm going to plug this in to the velocity equation, v of 2, and I'll calculate and get negative 26 meters per second. Notice I get a negative answer here. That's because I'm coming down towards the ground. Keep in mind, the equation I gave you, h of t, was measuring my height. So this is my velocity in terms of height. And it's negative because on that original parabolic flight path, I was originally flying up and then flying down. So now I'm coming downward at a rate of negative 26 meters per second. Question D, what's the speed at t equals 2 seconds? Speed is the absolute value of velocity. So if I take the absolute value of negative 26, I'll get 26. And in doing so, you get a positive answer because no matter what, I'm traveling a positive speed. The velocity with the negative is giving me the direction, traveling up or traveling down. I'm still traveling at 26 meters per second either way, up or down. The negative was just indicating my direction. Question E, what is my acceleration just before I hit the ground, which would be right there? Acceleration is the derivative of velocity. It's also the second derivative of position. So I have to find a of t, which is v prime of t. I've already calculated v of t, and I'm just going to take the derivative again. The derivative of negative 32t plus 38 is negative 32. So what is my acceleration right before I hit the ground? Negative 32. My acceleration is actually the same throughout the entire flight path, which makes sense. Acceleration would be when I'm already moving and I twist the throttle just a little bit harder. Well, I'm in the air here. I can't accelerate if I'm off the ground. I need my tires to be on the ground to be accelerating. So I'm actually off the throttle right now, and my acceleration is negative 32. Another reason why it's negative is because I'm actually slowing down just before I hit the ground. I'm accelerating up to the jump and then letting off the throttle throughout the flight and then slowing down until I hit the ground, and then I'm back on the throttle again. Let's find the average velocity during the first 2 seconds that I'm in the air. Well, average velocity is the average rate of change. F of b minus f of a over b minus a. So in this case, h of 2 is 12, h of 0 is 0, divided by 2 is 6 meters per second. So I'm averaging a velocity, or averaging a speed, of 6 during the first 2 seconds. If I wanted to calculate the average velocity the entire time I'm in the air, from takeoff to landing, it takes me 2.375 seconds from when I leave the ground until I touch down on the ground. So that average velocity would be h of 2.375 minus h of 0 over 2.375 minus 0. And that, of course, would be 0. Now, if I have a perfectly parabolic flight path, which I believe I did in this jump, my average velocity is going to be 0 because I'm finding the slope from when I'm on the ground until I'm on the ground. And that would be 0. It's a horizontal line. Lastly, I want to find the total displacement from 0 to 2. That's going to be just the numerator of the previous equation. H of 2 minus h of 0 is 12 meters. That's giving me my height change during the first 2 seconds. If I wanted to calculate my height change during the entire time I was in the air, from takeoff to landing, it took me 2.375 seconds to jump, takeoff to landing. So what is my displacement? 0, because I started on level ground and I ended on level ground. So while you might not think I'm using calculus while I'm riding a dirt bike, I actually am. I'm calculating all the time. I'm constantly adjusting velocities and acceleration. This jump that I'm hitting right here, I want to make sure I'm going to go ahead and hit it fast enough where I don't go too long or I don't go too short. So I'm constantly, well, not calculating calculus, in my head the whole time by taking derivatives all the time, but I am making adjustments based off of calculus concepts. If I feel that I'm going too slow as I'm coming up to a jump and I'm going to come up short, I need to accelerate. The second derivative is acceleration. For me, I just grab a handful of throttle like I did right here, and make sure I'm going to clear the next jump. So I'm using my math problem-solving skills to hit all these jumps and constantly correct by going too fast or too slow while I'm riding a dirt bike. So you actually do use calculus in real life. I'm not actually doing equations in my head here, but I'm using these concepts, and that's what's important. The better I am at understanding these concepts, in theory, the better I'd be able to ride this motorcycle. So I hope you learned some things here between the relationships between velocity and acceleration. So I hope you enjoyed the video. I certainly enjoyed riding the dirt bikes. Take it easy.